going to remind you what standard form looks like here real quick. So this is the format we're going to get these equations in today. So y equals ax squared plus bx plus c. Now, we've already written quadratic equations from 2 points. We did that a couple of days ago, but specifically we had a vertex and a point, and then we used the vertex form, which you can do. So my question under here says, when and why do I need 3 points? Because I'm going to tell you today you need at least 3 points to do this. And the when is if you don't know the vertex. If you don't know the vertex, we can't use that vertex form to help us just do it with 2 points. So we're going to need 3 different points or more. Most of these questions are going to have more than 3 points that we're going to work on, but you need at least 3 points to do this. All right, the why you need 3 points. Okay, in this lovely formula here, you have variables that you don't know, letters A, B, and C. So if you have 3 variables, which I do there, to solve for those 3 variables, I need 3 equations, just like we did in our systems. So that's the reason you have to have at least 3 points. If you have more than 3 points, then you can work with that as well, but you have to have at least 3 points to write a quadratic equation if you don't know the vertex. All right, so each one of these in example 1, this is one method, and I'm going to show this to you, and I'm going to have you do one problem like this on the homework. So I'm not going to do all of these because they take up a little bit of space. So I'm going to do, which one are we going to do? I'll tell you what, I'm going to do the first one because it has kind of a weird thing to it. All right, so I'm just going to do the first question on here. We're going to skip B and C. All right, we're just going to do 1. All right, now, here's the deal. You're going to use, and don't write this again, you guys have it at the top, I'm just writing it so you can see it on the screen right now. We're going to use the formula y equals ax squared plus bx plus c, and we're going to try and solve for a, b, and c based on knowing these 3 points. Okay, what I'm going to do is I'm going to write an equation that contains each of the points separately. All right, so I'm just going to try and use a different color for each one. Here's all you're going to do. I'm going to take the first point that they listed there. They don't have to come in a particular order. Everywhere I see a y in this formula, I'm going to put 36. And everywhere I see an x, which is going to be 2 different places, I'm going to put a -3. So I'm going to write 36. Okay, now it's a times the x value squared. So the x value is -3. We're going to square that. Not the a getting squared, just the number. Plus b times that x value, which is -3. And these always just end with plus c because you don't plug anything into that last term in the general or in that standard form. It's just a c by itself. There's no x there. Now, what I will tell you, let me simplify this, right? So I had 36. What do you get if you square -3? Bless you. 9. So I'm just going to write this first term as 9a. Now, this is a little weird. In the middle, it's plus b times -3. b times -3 would make this a minus sign. So it's going to be -3b. That first number in front of the a should always be positive because you're going to be squaring something, but the second number could be positive or negative. Now, the last thing will always be just plus c because we didn't plug anything into that, so that'll always end with a plus c. Okay, now, all I'm going to do, I'm going to repeat that process, but I'm just going to grab the next point. So again, just everywhere you see an x, you're going to put a 0, and everywhere you see a y, you're going to put a 3. So I'm going to do 3 equals, now this one's a little nicer because I'm going to plug in a 0. A times 0 squared plus b times 0 plus c. So if I simplify that, that 0 is going to wipe out the first 2 terms because a times 0 squared would just be a times 0. So there would literally be nothing there. This would go away. B times 0 would be, yep, and then this would just actually be equal to c. All right, and then the final point they give me is 4 and 15. So again, I'm just putting the y in place of y, so I'm going to get 15. A times 4 squared plus b times 4 plus c, and then I'm just going to simplify it over here to the side. So keep the 15. What's 4 squared? 16. So that first term will be 16a. Now the middle term is b times a positive 4, so it would be plus 4b, and they always end with a c. Okay, now, if we're doing our systems unit, you could solve this using a system. Probably if I was doing it, I'd plug in 3 for C and go from there. You can do that. Or I thought we might review how to put this into a matrix real quick. So if you wanted to use a matrix, you could do that too. So we're trying to solve for A, B, and C to write this equation in standard form because I'm going to plug those numbers back in for A, B, and C right here when I answer the question. So to write a matrix here, and I probably should have written this backwards. If you write the matrix, though, you want to do the equation, like I basically need to take, like put these guys on this side when I do the matrix. So I'm going to do that in a second. So for my matrix, my first equation, I'm just going to go A, B, C. So I have 9A, just write the 9. Then I have minus 3B, so I'm going to write the negative 3. The C value will always be 1, always. Now, the middle equation, actually, sorry, and then we have that line, that's equal to the 36. But I want what the equation is equal to be in that far column. Yeah, so we're just going to do that second equation. I don't have an A, I don't have a B, I have one C, and then that one was equal to 3. And then the third equation, you have the 16A, so just write the 16, 4B, and again, that third column will always just be all ones. It would be 1C. That equation was equal to 15. So this would be my augmented matrix for the system. So that's a good review of that. Now, what I want to do is we're going to use Desmos to do this, right? Or you could do it by hand if you wanted to. You could solve the system, but I think the Desmos might be a little bit faster. So we're going to enter this in Desmos, and then to get the answer, I'm going to do that reduced row echelon form here in a second. So let me slide this to the side. Okay, if you guys want to pull up Desmos, I have just the graphing calculator pulled up on mine, but I want to use the matrix. So maybe I'm going to move this. Nope, I'm not. What is going on here? Okay, if you do go over up at the top, there's like a little green graph if you're on the screen, bless you. You can just switch that to the matrix calculator, or you can go to desmos.com and just select the matrix calculator, whatever is easier for you. And let me move that so we can actually see it. So I'm going to grab a new matrix and type in what we just wrote, but we're going to have 3 rows and 4 columns to match what we did. And if you guys remember, you can just hit like the tab between, or you can hit the arrow key and it should just move to the next open spot. And I would just take a second, make sure we didn't mistype anything or anything like that. And then you can hit enter. That'll be matrix A. To get the solution, if you guys remember doing this, you just hit this RREF and it does all the work for us to solve the system. And we put in, that was matrix A. Of course, I cannot see the answer. Hang on a second. Move this. There it is. All right, so on the screen there, if you guys can see it, I'm just going to come back and write it on my paper real quick. Hopefully at the same time. So should see the identity matrix, that 1, 0, 0, then 0, 1, 0, 0, 0, 1. Now, they don't put the line on the Desmos, but that fourth column, that'll be your solution set. So we have 2, we have -5, and we have 3. Now, the way this works, if you looked how we wrote the equations, okay, hopefully everybody's got that. Let me go back to the screen here. All right, so the way that we laid these out, it was A, B, C, A, B, C. So in terms of my answer, this goes A, then B, then C. Those are going to be the A, B, and C values that I'm going to plug into that standard form. So don't write this again. I'm just writing it so you can see it on the screen. The actual answer to the question is for me to sub those numbers in place of A, B, and C. So it would look like this. Y equals 2x squared. The B value is -5, so it would be minus 5x. And then the C value is 3, so it would be plus 3. That quadratic equation, I'm on the bottom there a little bit. That quadratic equation goes through the 3 points that we had in that original problem. So I'm showing you how to do this. This is one method for finding the A, B, and C values from standard form. I'm going to show you another method on the back. Is anybody having a question? Okay. All right, now, this I think you will actually like a little bit better. And these ones on the back are going to have more points, but this is maybe a little bit faster because you're not going to have to write out a system of equations. So what we call this is a quadratic regression. And again, you need at least 3 points to do this. If you guys look down, I've got a bunch of data on a graph, and I've got the data in a table, so a couple of different formats to show you this today. But I'm going to go ahead, I'm going to use this first example that's on the back, use the data to kind of go through how to do this with you. But this is a guy throwing a discus. All right, the x value is how far away the discus is from him, and the y value is the height of the discus in the air. So we're going to use this data to illustrate the quadratic regression. So I'm going to write the directions up here, but let me pull up my desmos. Now, on your desmos, you want to go to the graphing calculator screen. So if you got the little green, it's got a little green thing next to it, or you can go to desmos.com and click the graphing calculator. I promise this is not hard, but it's a little bit weird. So do you guys see there's a plus sign? It's right here. You're just going to, whoa, you're not going to click on your Power School. You're going to click on the plus sign. All right, and then under that menu, you want to select table, because we're going to actually type the data values into the table. So just go through here, like when it gets the plus sign, just make a table. Okay, now all I'm going to do is type in your data to the table. So that's what I'm going to write. What I'm going to use is this little piece. Let me see if I can pull that to the side so you guys can see that on the screen. So I'm just going to type these into the x and y. So the x's just go like 1, 2, 3, 4 up to 10. So I'm just typing that in. And then I'm just going to go back, type the corresponding y value. It's a little tricky because they're all decimals here, so make sure you're typing everything correctly. If you just hit return, it should go down to the next line. And it's super important we type these correctly, because if we type anything a little bit off, it can mess up the equation. This is going to create a scatter plot that you guys will be able to see. Oh, I should have told you to do something. I'll tell you to do it in a second. But just type these data values in. I'm sure you guys are faster than me. And you have to have the same number of x's and y's. We can't have that unbalanced. So hopefully we've got that in. And I should have showed this to you guys a second ago. There is, in this little blue bar over here, there's like a little magnifying glass in the corner. If you want to click on that, that will really zoom in on your data. Now mine's weird because I've got my thing to the side of the screen, but if you want to click on that, if your data is kind of spread out, they will kind of hone in on it. That is going to be what we're going to write a quadratic model for. Okay, so after you type in your data, and if you want to zoom in, you can, but you don't have to. There is a kind of a weird symbol. It's supposed to symbolize a scatter plot. They have it in the next to the y. That's not the one I want. I want the one over in this blue bar over here. You're just going to click on this little symbol right here, and it'll say, it says add regression when I hover over it. Now, it'll automatically, because it's programmed to do this, do a line. You just want to come down to this drop-down menu. We're working with quadratics, so you're going to click on that, and you got to change that drop-down menu to be quadratic regression. And then what it'll do is it'll tell you the A, B, and C values. Now, a lot of times if you're working with data, these are super weird numbers. Like we had a nice one on the one that we did on the front, so it just kind of depends on the question. So if you read my question here, it asks you to round to nearest thousandth, which would be 3 decimal places. So I'm just going to try and grab that and write this for our quadratic model here. So this is the regression. This is Desmos doing all the math, basically solving those systems for us. So I'm going to write negative, let's see, 0.3 decimal places. I'm going to go 0.27. That'll be next to your x squared, so that's your quadratic term. Just rounding these to 3 decimal places. Your linear term is going to be plus, let's see, 1.058. That has an x next to it. That's your linear term. And then your constant, which is the plain number, which is this little lovely decimal, I'm going to do plus 0.672. And then if you guys do want to look at the graph a little bit, you can see it. You can kind of scrunch it, but it'll show you how well it approximates the data. And we've got plenty of time. Don't get anxious here. Okay, now here's the question, because these usually ask you to do something with the equation. So this says, what will be the height, which is the y value here, of the discus when it's traveled 15 meters from the guy? Remember, the distance from the guy is the x value. Now, literally, all you have to do, it's giving you the x value, it's saying x is 15. So if you want to find out the y value when x is 15, you're just going to plug 15 into that equation. That's all you're going to do. So I'm going to grab my calculator here real quick. And I'm going to do that negative 0.027, plug in 15, make sure you square it. I'm just using their formula that we got on the desmos. Everywhere I see an x, we're just going to replace it with 15. And you guys can see I get about 10.467, and if I'm looking at the data here, this is in meters. So that would be the height of the object. And then we'll fix the next one after we come. You guys already know this. If you have a data set that is a horizontal table, right? This is horizontal, wasn't on the graph, didn't give me the points. Whatever the top row is, that should be your x values, and whatever the bottom row is, that should be your y values. So just so you know, that's the typical notation for any horizontal table, or it's supposed to be. So we're going to do that quadratic model. So I'm just going to go through step by step again. So let me pull my desmos up. I'm trying to keep that data so you guys can see it. I'm just going to go up here and X out of the original one I did so I can show you the steps one more time. So first thing you got to do is you got to add the data. So you're going to click the little plus sign over here and then click on the table. And then we're just going to type the x values, which, sorry, most of these are decimals. So I'm just typing that top row of that table down this column. Those should be our lovely x values. And if you guys see how it says in there, like it says 1.0, you don't have to type the 0.0. You can just type 1. And then I'm going to go down the other column and type the corresponding y values. If you hit enter, it should just take you down to the next piece in the table. Make sure I don't tape it wrong. Okay, and then if you guys remember, if you want to click on the little magnifying glass that's down on the corner, this should kind of zoom to the data so you can see it a little bit better. And hopefully you guys can kind of, I'm going to scooch that over just a little bit because I got my screen split with the notes here. But if you click on that little magnifying glass, it just kind of zeroes in on your data. To get the actual equation, you're going to come over here and click that little weird button that looks like a line with dots. And then you got to change this because it'll automatically do a line, but we don't want a line, we want a parabola. So we want the one that says quadratic. So you're just going to change that. And this one actually has nice numbers to it, unlike the previous question. So it just kind of depends on the problem. You might have nice A, B, and C values. You might not. I'm going to write the equation here on my note paper here. So the A value is just negative 16. So negative 16x squared, that's your quadratic term. The B value is 12. So this is 12x, that's your linear term. And then plain number is 10. That's all you got to do. That is the quadratic equation that goes through all those points that they gave us in that table. And this has a little bit different question than the previous problem. So let me pull this on the screen here real quick. So this was, sorry, I didn't even read the problem to you before we started it. So this is somebody up in the stands at a football stadium, and they're going to throw like a toy football down. And this is the time in seconds and then the height of that football. So you can see it's going down. The heights are going down as it goes. You saw that on the picture there. This says if the football's not touched by anybody, so like nobody catches it, on its way to the ground, it says about how long does it take the football to reach the ground. Now, previous question that we did gave us an x value and wanted a y value. This is saying about how long, so that's the time there. So it's actually asking me for an x value, so it's not giving me something to plug in. So I want to pull the graph back up so you guys can see it here. So if I'm looking at this graph, where would you look to determine how long it would take the football to come back down to the ground? Like if you had the graph there, which we do, where would the football come back down to the ground? You what? Yes, you're just like, look, so basically here, this would be in the first quadrant, right? So this is the person like throwing the football and then gravity's going to drag it down to the ground. So when it's on the x-axis, that's where it would hit the ground. The x-coordinate of that point is the time, the y-coordinate's the height. So if I'm on the ground, my height would be 0. So you're just looking for that x-intercept right there. So my answer to that second part of that question, it's just, you can click right on it on the Desmos. And I'm not even on the right screen. What am I doing here? Sorry. That's our review for tomorrow. So this would be, it was 1.25 seconds would be how long it would take. Does anybody have any questions? That's it. That's it. Short today.